Solving systems by using elimination. So the reason I put linear combination down there, sometimes elimination is also referred to by linear combination. First, I want you to stack like terms. All right, so that's what I have over here, my x's together and I have my y's together. Then it says create a pair of opposites. Remember, that means opposite sign and same number. Okay, opposite sign, same number. So you might have to multiply one of the equations or both of the equations in order to get that to happen. So we're going to look here. These, I have a 3 and a 5 with the x. No opposite signs, no same numbers. No opposite sign, no same numbers. But I have a 5 here and a 1 here. So it will be really easy for me to multiply this one times 5. But if I multiply it times 5, that's going to be a negative 5, and this is a negative 5. So I'm going to have to multiply it also times a negative. I'm going to rewrite the first equation, 3x minus 5y equals 7, and then I'm going to distribute this negative 5 to everything. So I get negative 25x plus 5y equals a negative 95. All right, so now I'm going to combine those, so I get negative 22x. This cancels, equals a negative 88. I divide by a negative 22. I get x equals 4. Okay, so now that I have 4, what I'm going to do is I'm going to take this 4 and I'm going to plug it back in. It doesn't matter where you plug it in, I'm just choosing that one. So I'm going to have 5 times 4 minus y equals 19. 20 minus y equals 19. I'm going to subtract 20 from both sides. I get negative y equals negative 1. I'm going to divide by negative 1 to get y by itself. I get y equals 1. So my answer is 4 and 1. All right, so now I'm going to remind you again, because we talked about this every day so far. Remember, I can have a point as a solution. I can have no solution. And I can have infinite solutions. Okay, so I can have any of those 3. All right, so now let's look at a problem. All right, so remember, we're looking for stack our terms. Do we have them together? Yes. Create opposites. Okay, so I have opposite signs on both of them, but I notice that if I multiply this one times 2, then my y's will cancel. So I'm going to have negative 8x minus 6y equals 36. Then I'm going to rewrite this one. So 5x plus 6y equals negative 9. Draw my line, add straight down, negative 3x, this is 0, equals 27. I'm going to divide by a negative 3. I get x equals negative 9. So x equals negative 9. Now remember what we do with that? You are freaking awesome. Yes, we're going to take this and we're going to plug it back in up here. You guys are awesome. So now I have 5 times negative 9 plus 6y equals negative 9. Negative 45 plus 6y equals negative 9. I add 45 to both sides. 45's cancel. I get 6y equals 36. Divide by 6. Y equals 6. Okay, so my answer is negative 9 and 6. Awesome. You guys are doing a great job. All right, so now we're going to look at the next problem. Okay. So the next problem, what do we want to multiply times? Okay, let's just say we're going to get rid of the x here. So I'm going to multiply this times negative 2 because that will make a positive 10. So I'm going to rewrite the top one. And then I'm going to distribute the negative 2 to everything. So I get 10x plus 4y equals 0. So remember, this is what I was trying to get rid of. So those cancel. Now, I'm not getting rid of these, so I'm not canceling. So I'm actually going to add those. So negative 4y plus 4y, that's 0. 0 equals 0. Is that true? Yes, that's true, right? 0 can never not equal 0. So then that is infinite solutions. Okay. Infinite solutions. Very good. So I know you guys right now are like, oh yeah, we like those because those are really easy. I know, not much work for those, right? All right, so then let's look at the last one, and I'm going to choose to get rid of the x's again. So I'm going to multiply this top one times 2. So 14x minus 16y equals 4. And then I have negative 14x plus 16y equals, negative 16. Draw the line, add straight down. Those cancel. Okay, so again, negative 16y plus 16y, that's 0 equals negative 12. Is that true? No. So this is no solution. We are done. Have a good day.